In this lesson and the next lesson, we're going to be talking about binary trees and binary search trees as a particular data structure for storing data that needs to be retrieved quickly. In the diagram in front of you, I'm showing you a binary search tree. But let's start out by first discussing what binary trees are, and then we'll talk specifically about a binary search tree. A binary tree is a data structure made up of nodes with a root node, that's the node number 8 in this example. And underneath the root node will be a series of child nodes. For a binary tree, that means a left child and a right child node only. Now there is such a thing as a tree data structure where you can have as many child nodes under a parent as necessary, but for a binary tree, you can only have 2 child nodes, a left and a right node. So in this example, the 3 and the 10 are example of child nodes, and the 8 is the parent node to the child nodes 3 and 10. Looking on down the tree, you'll see that 6 and 1 are child nodes of the parent node 3. And going across to the right, you'll see that 14 is the only child node of the parent node 10. And that also demonstrates an important property in that a parent node does not have to have 2 child nodes. It can only have 1 or 0. But it can have no more than 2. Now, what makes this particular tree a binary search tree is the way the data is placed into the tree. So for example, the first piece of data entered into the tree was the 8, and so it becomes the root. Then, as we add more data to the tree, we either move to the left, to a left child, if the data is less than 8, or to the right if the data is greater than 8. So you'll see that the 3 is placed in the left child node of 8, and the 10 is placed in the right child node. The 6, for example, starts out to the left of 8 to the 3, but because 6 is greater than 3, it went into the right child node of 3. Look at 4 as another example. 4 is less than 8, so it goes to the left. 4 is greater than 3, so it goes to the right. And 4 is less than 6, so it goes to the left. So that's how data is placed into a binary search tree. And one of the nice properties of binary search trees is that it's very easy to find the minimum and maximum values. All you have to do to find the minimum value is travel the left nodes until there are no more left nodes to travel, and that finds your minimum value. And to find the maximum value, travel all the right nodes until you get to the farthest right node that has no more right nodes, and that becomes your maximum value. So those are the properties and definitions of binary and binary search trees. So let's begin our implementation in this lesson by creating a node class. So let's bring up code blocks. And our node class begins with, of course, class node. We'll only have a public section of the class, and the fields will be a field for the data, which is of string type, and then a field for the left node, so we have a pointer to node class left, and a right node pointer, like so. Finally, we'll have a constructor that simply places data into the data field and sets the left node to null so that we can assign the pointer as we place it in the correct place in the tree, and a right node to null. So that's our class definition for node. So with that, we're ready to move on to the next lesson where we're going to see how to build the binary search tree class and then see how to use it to sort and search for data.